Hey everyone. So we're nearing the end of chapter 9. We've got 2 lessons left. We've got this one and then we've got section 9-6. So today what we're going to talk about is solving quadratic equations using the quadratic formula. Um and you guys, this quadratic formula is fantastic. It will work every single time. So we've been learning a lot about different ways to solve quadratics. Um, and all of these different methods we'll talk about in the next video. But this quadratic formula is a technique that will work every single time you try it. Okay, so our essential question, how can you derive a formula that can be used to write the solutions of any quadratic equation in standard form? First off, what we're going to have to talk about just before we get into the lesson is the discriminant, okay? The discriminant, and that's going to come into play with our, I believe it's like their third example today, is just going to be this b squared minus 4ac. Okay, so whenever you look at your, remember, standard form, you've got ax squared plus bx plus c. So your b term is this middle one, a term is the first one, c term is your last one. Okay, but that's just a discriminant. And then, yeah, let's go ahead. Let's look at the actual formula for a quadratic formula. The real solutions of a quadratic formula, ax squared plus bx plus c equals 0, are, here's our quadratic formula. Okay, and there's a little song that goes with it to help you remember it. It's kind of along the tunes of Pop Goes the Weasel. You don't want to hear me sing it, so I will just make sure I have a video ready for you guys tomorrow that you can listen to it. But it's always going to be opposite b plus or minus the square root b squared minus 4ac all over 2a. Okay, so you're taking, here's your b term, here's your a term, here's your c term, and it's literally just a matter of plugging all of the numbers in. And then again here is that discriminant. Okay, anytime we're calculating the quadratic formula, this discriminant always needs to be greater than or equal to 0, because remember, this is what's underneath the square root sign here. This always needs to be positive. All right, let's go ahead. Let's do 2 examples. So I will do for sure one with you, maybe a second. But solve 2x squared minus 5x plus 3 using the quadratic formula. So here's the first thing that I suggest doing. Write out the formula. Opposite b plus minus the square root b squared minus 4ac all over 2a. Okay, take all of your terms and plug them in. So notice how I said opposite b? Because right now you have -5, so it's the opposite of -5. Then you've got plus minus the square root, again your b term, so that's -5 squared minus 4. Your a term is 2, your c term is 3, and that's all over 2 times a. Okay, now let's simplify this. So that turns out to be 5. If you grab your calculator, so we've got 25 minus, let's see, that's 6 times 4, which is 24. So 25 minus 24, that turns into 1 all over 4. So then you've got 5 plus and minus 1 all over 4, because remember the square root of 1 is just 1. So you have 2 solutions, which, you guys, it's a quadratic. You're supposed to have 2 solutions. So you've got 5 plus 1 over 4, 5 minus 1 over 4. So 5 plus 1 is 6. over 4, and if you simplify it, that's 3 halves. So that's one of your solutions. Then you've got 4 over 4, which turns into 1. So those are your two solutions. Just for the sake of the video and for time, I am not going to do any more of these. They do say for the directions to round your solutions to the nearest 10th. Okay, and I'm just going to give you guys a hint. Number 2, for sure, you will need to round to the nearest 10th. I believe number 3, you're going to have to as well. Okay. This one, so number 1 should give you 2 nice whole answers. For this one, for number 4, oopsies. For number 4 here, make sure that you add this 1 back over here so that you have a C term, because right now this is on the other side. Add it over to the other side so that you've got a C term. And that one will give you a, it's not going to be a whole number, but it'll still be a nice number. Okay. So now, the number of northern Rocky Mountain wolf breeding pairs, X years since 1990, can be modeled by this function here. When were there about 35 breeding pairs? So basically what they want you to do is plug 35 in for Y here. And then kind of along the same lines of number 4, or the last example you just got done doing, get that 35 over to the other side because you want this entire thing to equal 0. That's how you know that you'll be able to use the quadratic formula then. So that'll be what, 38? Okay, let's use that quadratic formula. Opposite b plus minus the square root, b squared minus 4ac all over 2a. Okay, your b term is 1.8. So that's opposite of 1.8 plus minus 1.8 squared minus 4. Your a term is 0.2. Your c term is negative 38, and that's actually really important because now this stuff is all going to turn positive, and you want that to be positive. Okay, so you've got negative 1.8 plus minus, oopsies, I forgot that this is all over 2a. 2 times 0.2. Okay, 1.8 plus minus, and then grab your calculators, take this entire thing, and you can simplify it. So let's see, 1.8 squared minus 4 times 0.2 minus 30, or times negative 38, should turn out to be 33.64 all over, this should be 0.4. Okay. Now, let's figure out what 33.64 is going to be once you take the square root of it. And if I just grab my calculator and I try that, I believe that's 5.8 over 0.4. So I've got negative 1.8 plus 5.8 over 0.4, and then negative 1.8 minus 5.8 all over 0.4. So then, let's see, negative 1.8 plus 5.8, that'd be 4 over 0.4. So 4 divided by 0.4 will give you 10. Negative 1.8 and negative 5.8 divided by 0.4, that will give you negative 19. Okay, now if we go back and we just read through the problem again, the number of Northern Rocky Mountain wolf breeding pairs X years since 1990. Okay, so this is X equals 10 and this is X equals negative 19. Does it make sense for us to have negative 19 years? Nope. So that all of a sudden no longer is a solution, but that is. And since we started in 1990, we're adding 10 years to it. So it should be in the year 2000. That is the solution that they are looking for. All right. I'm going to quickly talk about this last concept here. Not that. This concept here, which you already have the basic idea, like you have all of these graphs and you have this, but we're going to talk about the discriminant really quick. Okay? The discriminant, you guys, again, like we talked about before, is just b squared minus 4ac. So it's basically everything that's underneath the square root sign in the quadratic formula. And here's what this is saying. Anytime that this b squared minus 4ac, anytime when you evaluate it that it's greater than 0, you are going to have 2 real solutions or 2 x-intercepts, basically meaning that it's crossing the x-axis twice. If you get b squared minus 4ac to equal 0, you're going to have 1 real solution or 1 x-intercept. So basically this graph is just going to come down here. It's going to hit your x-axis, and then it's going to go straight back up. And then lastly, if you get a number less than 0, so if your discriminant when you calculate it is less than 0, then you have no real solutions or no x-intercepts. Okay? So let's take a couple seconds. I'll do these next 2 examples with you, and then I'll have you guys do 7, 8, and 9 on your own. Okay. So determine the number of solutions of x squared plus 8x minus 3. B squared minus 4ac. B is 8. So let's take 8 squared minus 4. Your a term is 1. Your c term is negative 3. So 8 times 8, that turns out to be 64. Negative 4 times negative 3, that turns out to be 12. So you come up with 70, not 72, where did that come from? 76. Okay, so since this number is greater than 0, you have 2 real solutions. Okay, now let's try this one. First thing you're going to want to do is get this over here. So you've got 9x squared minus 6x plus 1. And now that it's equal to 0, you're good to go. Okay, so your b term is negative 6. So negative 6 squared minus 4. Your a term is 9. Your c term is 1. So you get 36 here. 4 times 9 is also 36. So you come up with 0, which means that there is 1 real solution. And that's all they're asking for, you guys. So your job right now is to make sure that you have 1, 2, 3, 4. So those are just the basic solving using the quadratic formula. And then 7, 8, 9. If you have any questions, make sure you just write them off on the left-hand side. I will check in tomorrow. If you've got any questions, we'll talk about them. All right, we'll see you guys tomorrow. Have a great night.